In this research, we're going to present on prognostic modeling of mild cognitive impairments to Alzheimer's disease conversion using cognitive, functional, and CSF biomarkers in ADNI. This is being presented by Salah Uddin, Saviour Ntow, and Mahmudul Hasan from Minnesota State University in Mankato. Alzheimer's disease is the most common form of dementia and is not a normal part of aging. It is an irreversible brain disorder that mainly affects older adults, and by 2060, about 14 million people in the United States are projected to be living with this disease. In this study, 748 participants with mild cognitive impairment from the ADNI dataset were followed, and more than 36% progressed to Alzheimer's disease dementia over a median follow-up of 3.1 years.
The ADNI dataset gives us high-quality multimodal data, including cognitive and functional scores like ADS-13, FEQ, MMSE, APOE4 genotype. We also use cerebrospinal fluid biomarkers like A-beta-42, tau, phi-tau, and we also use some demographic variables like age, sex, and education. In this study, our aim was to compare a traditional multivariable Cox model with 3 modern machine learning approaches like ElasticNet, random survival forest, and XGBoost. To do this data, we randomly split 70-30 into training and testing set. We then fitted 4 models. The key finding of this analysis is that the baseline characteristics is significant since all the p-value less than 0.001. On the independent test set, the Cox and ElasticNet models achieved AC index of 0.844. The random survival forest reached 0.839. However, the XGBoost Cox model performed the best with C index 0.851, time-dependent area under curve approximately 0.90 for 1, 2, and 3 years. All models showed good calibration. We also checked Bayer index, and it lies between 0.06 to 0.15. To do this analysis, we did sharp analysis and checked which variable is important, and we found ADS-13, FEQ, A-beta-42, tau, and phi-tau are the most influential variables. Finally, we are planning to do some external validation of our result to make it more logical.